We're standing right on the edge of the next industrial revolution. It's a shift that's going to be just as huge as the invention of the assembly line itself. It's called smart manufacturing, and believe me, it is completely changing the game for how we make, well, everything. So let's dive in and see what this is all about.
I want you to start with this question, just for a second. What if a factory could do more than just follow commands? What if it could actually sense what's happening, analyze it, and even predict its own future? What if it had its own digital nervous system? This isn't science fiction anymore. This is the big idea that's powering smart manufacturing.
And this whole concept of a thinking factory, it's so revolutionary that it's earned its own name, Industry 4.0. I mean, think about it. We had steam power, then electricity, then computers. Well, this is the fourth major leap forward.
So what are we really talking about here? At its core, smart manufacturing is about fusing our physical industrial world with a really powerful digital intelligence. We're talking about using incredible technologies like AI and the Internet of Things to jump from simple automation, where machines just follow commands, to true autonomy, where the entire system can think, learn, and adapt all on its own.
And it's so important to get this. This isn't just about buying shinier, faster robots. No way. This is a fundamental rewiring of how we design, create, and deliver pretty much every product you can think of. It's a total paradigm shift, and that is why we call it the fourth industrial revolution.
So, what kind of tech is actually making all this happen? Let's pop the hood and take a look at the core components of the smart manufacturing toolkit. These are the real building blocks that give a factory its new intelligence.
First up, we've got the Internet of Things, or IoT. The easiest way to think about this is as the factory's sensory system. We're talking about thousands of tiny sensors embedded everywhere, in machines, on conveyor belts, all through the supply chain. They are constantly feeling, listening, and watching, collecting this massive, non-stop stream of real-time data on everything from temperature and vibration to location and pressure.
But all that data would be totally useless without a brain to make sense of it, and that is where artificial intelligence steps in. AI algorithms are the thing that sifts through that absolute flood of information coming from the IoT sensors. They spot patterns a human being could never see and make lightning-fast optimized decisions. It's literally the cognitive engine of the smart factory.
Okay, and this is where it gets really, really cool. The digital twin. Imagine a perfect virtual copy of the entire physical factory that lives in the cloud. It's constantly being updated in real time with all that data from the IoT sensors. So what does that let you do? Well, it allows the factory to run simulations, to test out new processes, to predict failures, all in a safe, virtual space without ever having to shut down the real-world operation. It's kind of like the factory has its own consciousness.
So when you put these three things together, they create this complete digital nervous system. The IoT gives the factory its senses, gathering all that raw data. The AI acts as the brain, turning that data into actual insights and decisions. And the digital twin? That's the simulation space, the imagination, where ideas can be tested and perfected. Sense, think, simulate. It is an incredibly powerful loop. Okay, so that's the theory. But how does this amazing toolkit actually translate into real-world results? Let's look at some actual concrete applications where smart manufacturing is already making a huge impact.
All right, our first example tackles a classic manufacturing headache: quality control. I'm talking about the challenge of quickly and accurately identifying these tiny little codes engraved on thousands of metal parts as they're just whizzing down an assembly line. You see, the traditional way of doing this is slow, and let's be honest, human error is always a risk. But the smart solution? It's a lightweight AI model running on a tiny, super affordable computer. It uses a camera to read those engraved codes in real time with unbelievable accuracy. It completely automates a really tedious process and makes sure that no faulty part ever slips through. And this just shows you the power of this technology. Get this, the AI model achieved a 94.8% recall rate. That means it correctly identified nearly every single character. That is a level of precision that is just incredibly difficult, if not impossible, to get with manual inspection, especially at high speeds. Okay, for our second example, let's move from quality control over to logistics. Now, in a massive, bustling factory, a surprisingly huge amount of time can be wasted just looking for things. Tools, equipment, even those automated vehicles that zip around. The challenge is basically trying to find a needle in a haystack, except the haystack is constantly moving and rearranging itself. The solution here is so clever. It uses the existing Wi-Fi signals that are already blanketing the factory. A machine learning algorithm analyzes the strength of those signals to triangulate the exact position of any tagged asset. And all of this information feeds right into that digital twin we talked about, giving managers this kind of God view of the entire factory floor.
And the precision here is just remarkable. The system can locate any asset with a maximum mean error of just 2.8 meters. Now, in a sprawling industrial complex, that means you can digitally pinpoint a specific piece of equipment to within just a few steps. That is an absolute game changer for efficiency.
Now, this all sounds pretty incredible. And it is. But if it's so great, you might be asking, why isn't every single factory smart already? Well, like with any massive technological shift, there are some pretty significant hurdles to overcome. The research consistently points to three major roadblocks. First, the cost. And it makes sense, right? Upgrading an entire factory with sensors and servers and software, that's a massive investment. Second is integration. Trying to get all this brand new tech to talk to your old legacy equipment, it's incredibly complex. And third, you need the right people. You need a highly skilled workforce that gets data science, AI, and cybersecurity, and that talent pool is in really high demand.
And that's not even the whole story. Companies are also wrestling with things like data security, network latency, and creating data standards so everything can speak the same language. And of course, there's that big societal question about the impact on the existing workforce.
So yeah, the challenges are very real, but the momentum behind this is absolutely undeniable because the long-term benefits are just too compelling to ignore. So let's look at the future this technology is busy building right now.
I think this quote from a 2024 study on digital twins just perfectly captures the feeling in the industry. Yes, it's hard, but the rewards for getting it right are just immense. I mean, think about it. Proactively fixing a machine before it breaks saves so much more money than the system ever cost to install.
When you get right down to it, smart manufacturing creates factories that aren't just more efficient. They're also more sustainable, more innovative, and way more resilient. This is really about building a better, stronger, and smarter industrial base for all of us.
And that brings us to our final thought. You know, the first industrial revolutions gave us things like mass production and the consumer society we live in today. This fourth one is giving us intelligent production. So I'll just leave you with this one question to think about. What new possibilities are going to be unlocked? What will we create when every factory is a smart factory?